Polar coordinates. We're going to start by complex plane. The complex plane has two axes. The horizontal axis is called the real axis, and the vertical axis is called the imaginary axis. So every complex number z equal a plus ib is represented by the point a xy, or by z of affix m, or m of affix z, or a, whatever. So if you have, for example, here you have 3 plus 4i, so this is a 3 in the real axis, this is 4, you graph it. Here minus 5 plus 2i, and always norm of z is the distance. For example, this is the real part, imaginary part here, and norm of z is radical x square plus y square. So this distance here is norm of z, as we said in the first video. Modulo is radical x square plus y square. A trigonometric form of a complex number. So as we said here, r it's called the modulo of complex number is radical x square plus y square. And if you want to do cosine theta here, it will be x over r. Sine theta is equal y over r. Okay, and if you want to find tangent of theta, so tangent theta is equal opposite over adjacent. Okay, so if you want to find theta, theta will be arctangent or tangent inverse of y over x. So you can find here the angle directly without the use of r, because if you use tangent you can get the angle. The angle in complex number is called the argument. Argument of a complex number is called theta. So now we had complex number written of the form z equal a plus ib. Our aim now is to write it in polar form. So z here, a, as you can see, and it means x, it is r cosine theta, plus b is r sine theta. So you can put r in factor, norm of z. It will be cosine theta plus I sine theta. So this writing is called polar form. So instead of having x and y rectangular form, this is a plus ib is called rectangular form. You can write it in the terms of r theta, where r is called the modulo and theta is called the argument of the complex number. How do we find theta? We do tangent inverse of y over x, and r is radical x square plus y square. Y be a complex number, graph in the complex plane that makes an angle theta with the x-axis. X equal r cosine theta, y equal to r sine theta. So we wrote it as r cosine theta plus I sine theta, and this is called the polar form. To convert from rectangular to polar form, not to do any mistake. Always in the first quadrant, if you have theta, if a plus ib here is in the first quadrant, the angle you're going to get is in the first quadrant. The calculator will give you, when you do, if a plus ib, and I mean here, suppose x is negative, you know, we are talking here in the complex plane. So here, if x is negative, for example, z equal minus 2 plus 2i, so directly this is here. So here in the if you do tangent or tangent inverse, theta we said is tangent inverse of y over x. So you're going to get 2 over minus 2. You're going to get, the calculator will give you directly in the second quadrant 3 pi over 4. Okay, so this will be given directly in calculator. Third quadrant, if it's in third quadrant, so you need to add pi, for example, y, because if you have, for example, minus 5 minus 10i, this is in the fourth quadrant. If you do theta, which is tangent inverse of y over x of 2, the calculator will give it in the first quadrant, because here it's positive. So the calculator will not know that we are talking in the third quadrant. So that's why the angle you're going to get, you add to it plus pi, add plus pi. In the fourth quadrant, the calculator, it will give you the fourth quadrant. For example, if you have 2 minus 2i, if you do tangent, you can try it now, theta equal tangent inverse of y over x of minus 1, it will give you directly minus pi over 4. Put, guys, the calculator, when you want to use pi, put the calculator in radian mode. So the only thing, this can be given directly. This is the, we don't have trouble directly when you use tangent inverse. The calculator will give it in the second quadrant. The only thing here you need to take care about, when you have in the third quadrant, you need to add pi. Let us take here example. I want to convert from rectangular to polar. You have z equal to radical 3 plus 2i. So this is in the first quadrant, theta is theta, you do r, so radical a squared plus b squared 4, and theta is equal tangent inverse 2 over radical 3, it will give you 30 degree. So this was written in rectangular form, now it's written in polar form. I want to tell you that, you know, from last year, the remarkable angle are multiple of 30 or 60 or 45. In multiple of 30 or 60, you have radically 3 over 2 and half. So any multiple, if it's given any multiple of radically 3 over 2, k radically 3 over 2 plus I k half, or vice versa, plus or minus, or vice versa, this is always, this is a remarkable angle, like this one. And if they are equal, for example, you know that the 45, if you have k radical 2 over 2 plus I k radical plus or minus also, if they are equal, so this is a multiple of 45. So here this is a multiple of 45. Here also multiple of 45. Here you have of that 4. So this must be multiple of 30 or 60. So always directly you need, you can know, since at the time you look at the complex number, it's in rectangular form, you know if it's a remarkable angle or no. So here let us go to the second one. This is must be a multiple of 45, because they are equal. So a minus 3 3, second quadrant, so the calculator will give you directly. So r equal 3 radical 2. If you do tangent inverse of y over x, you have minus 1 3 pi over 4. This is the polar form. Here this is in the third quadrant, so r will be a square plus b square 6. If you do tangent inverse, the calculator will give you pi over 4, as we said. You add to it pi, so it will be 7 pi over 4. This is, it's very simple to convert to polar form. Here this is a, this is b, this is in the fourth quadrant. So r is 8 and tangent inverse is y over x. It will, the calculator will give you directly minus 60 degrees. So this is the polar form. So I want to convert into rectangular form. You have it in polar form. I want to convert it into rectangle. This is very simple. You know cosine 50 minus radical 150 minus radical 3 over 2. Sine 150 is half. So this is the polar. For part B, this is in American. We use because I took this one from American Cycle. They use cis for polar form. It means 12 cosine 4 pi over 3 plus 12 I sine 4 pi over 3. Forget this one. Let us use this one. But in university, you're going to use this one because this is used in American program. So cosine 4 pi over 3, you know, it's minus half. Sine 4 pi over 3, it's also it's 1. So if you multiply it, you're going to get it is 4 pi over 3 minus radical 3 over 2. So you're going to get this one. Here cosine 50 and sine 50 are not remarkable angle. You need to use your calculator. Cosine 50 is 0.643, sine 50 0.766. You have this one. Pi over 2, cosine 90, and this is 0, sine 90 is I. so it's 15 I. So converting from rectangular to polar is something very simple. Before I continue, I want to tell you something very important. For example, if you have z equal, guys, 2I, I told you write it in polar form. Directly, this can be written as modulo 2 angle pi over 2y angle pi over 2, because if you want to write it in polar, for example here, you know that cosine 90 is 0 and sine 90 is 1. So directly when you have 2I, for example, this is 2 pi over 2. If you have it, for example, minus 3I, and if you want to write it in polar form, this is directly 3 and minus pi over 2. Why? Because if you do 3 into cosine 90 is 0, plus I sine minus pi over 2, this is minus I, so it's minus 3I. So always if you have 2I, 5I, 7I, you have angle pi over 2. If you have it as a number, for example 7, if you want to write it in polar form, directly this is 70 degree or 2 pi. Why? Because cosine 0 is 1, yani this can be written as 7, cosine 0 is 1, sine plus I sine 0 is 0, so you're going to get 7. But however, if you have it, for example, minus 5, this is nothing else than 5 pi in polar form, directly without doing anything. Why? Because this is 5, cosine pi is 0, but cosine pi is minus 1, sine pi is 0, so plus I times 0, so which is minus 5. So negative number, real number, its argument is pi. Positive number, its argument is 0. If you have I positive, its argument pi over 2. If you have minus I, its argument minus pi over 2. Okay? A complex number z written in polar form r theta, this is the way, and z prime r prime theta prime. Suppose you want to find z times z prime. I wrote here the proof. If you want to multiply z by z prime, you have r prime, and you multiply these two parentheses. So here, if you multiply cosine theta prime, here the real part I times I, and I square minus sine theta prime. For if you put I in factor, sine theta cosine theta prime plus cosine theta sine theta prime. You know cosine A cosine B minus sine A sine B is cosine A plus B. Cosine A sine B plus sine B cosine A, this is sine A plus B. So as you can see, this is a complex number whose modulo r prime and whose angle is what? Theta plus theta prime. So that's why if you multiply two complex number written in polar form, you multiply r and r prime, but you add angle theta plus theta prime. Okay, you add the angle, so you add theta plus theta prime. And if you want to do for the power, z, for example, for the power, for example, suppose I want z times z, so you multiply r by r, you have r squared, and you add the two angles theta plus theta to theta. If you have z times z times z, so you have r squared 2 theta times r theta, so you multiply this one by that one, r cube, and you add the angle 2 theta plus theta 3 theta. We can prove that if you have z power n, for r you do power n, but you multiply the angle by theta, so it will be rn and theta. If you have over z prime, the same way we did here, we can show it is r over r prime, but angle above minus angle below. So z times z prime, you multiply the modulo of the two complex number, but you add the angle. If you have the power, so you write r power n, but you multiply the angle by n. If you have z over z prime, you do r over r prime and angle above minus angle below. Note, you have z equal r cosine theta plus I sine theta, which is r theta. If you have z bar, It's r cosine theta minus I sine theta. You cannot keep it like this. Why? Because I want a complex number of the form cosine A plus I sine B. So you know that cosine minus alpha is cosine alpha from last year. So you can write it as r cosine minus theta plus I sine minus theta. So these are the same. But here it will give me in polar form r, and angle is what? Minus theta. So that's why argument of z, the angle of z, is equal minus argument of z bar. This is very important. We're going to use it a lot in the problems. So argument of z equal minus argument of z bar. I is, argument of I is pi over 2. If you have minus I, it is a 3 pi over 2 argument. If you have 1, it is 2 pi or 0. If you have minus 1, the argument is pi. Consider the following 3 complex number. Evaluate and write in polar form and Cartesian form. Euler form, you're going to take it anyway. ZZ prime, if you want to multiply ZZ prime, you multiply 2 times 3, 6, and you add the angle. So you're going to get 6 pi over 2. 6 pi over 2, since I have pi over 2, so 6i. Z over Z prime, so it's 2 over 3, angle above minus angle below. So pi over 3 minus pi over 6, it will give you 2 over 3 pi over 6. I want to write it in Cartesian form, in a rectangular form. Cosine 30 plus I sine 30, you have that. If you want to find minus Z double prime cube, we cannot keep the minus. Minus 1, it means 1 pi. Minus, if you have minus 2, you put 2 pi. Always r must be positive. So 1 pi, and you have Z double prime cube. So here you need to put a cube. So it will be r cube, so 2 cube. And you multiply the angle by 3. So you have, here you multiply 1 by 2 cube is 8. You add pi to 3 pi over 4. You have this one. And if you want to write it in polar form, it will be 8 cosine 7 pi over 4, which is 7 pi over 4, radical 2 over 2, plus I sine pi over 4, which is minus radical 2 over 2. And if you want to find the last one here, I have z cube, let me do it here, z cube, z prime square over z double prime 4. First of all, I start by r power 4. Z cube, I take the 2 here, I cube it. So 2 cube, I'm starting by the r. Z prime square, so times the 3 square. Z double prime power 4, so 2 power 4. Now for the angle, this is r. Now for the angle, I multiply the angle of z by 3. So 3 times pi over 3. Let me put it step by step. Times plus. I have z prime square, so I multiply pi over 6 by 2. Then over, we put minus. I multiply the angle of z double prime by 4. So minus 4 pi over 4. So you're going to get 9 over 2 pi over 3, and then you write it in a Cartesian or rectangular form. Evaluate. I'm not going to multiply 4 parentheses together. This is a remarkable angle since it's you have radical 3 and multiple of radical 3 and half. So here we write it in polar form. R is square root a square, 4 times 3 12 plus 4 16, which is 4, and theta is arctangent y over x is pi over 6. If you multiply power 4, you do 4 power 4 and you multiply pi over 6 by 4, 2 pi over 3. So this is a remarkable angle. You get this answer here. Find argument and modulo. You know 3i is 3 pi over 2. Here, this is in the third quadrant. R is 4, and argument is arctangent of 2 over 2 radical 3. This is 7 pi over 6. Here you have minus 2i. You do to minus 2i alone. This is r is 2 and the angle is minus pi over 2. Here it's 1 and pi over 3 because I have 1 here. So here this is alone and this is alone. You multiply these two and you add the angle here. You have 2 minus pi over 6. Important note, you cannot always, when you want to write a complex number, you need to write it as r cosine theta plus I sine theta. Since here you have minus, you cannot keep the minus here and you're going to tell me the angle is theta. So you need to do a thing such that you have same angle inside, and here positive, here positive. You know that this is in the second quadrant. In the second quadrant you go to pi minus theta in both. So cosine pi minus theta is minus cosine theta, and sine pi minus theta is sine theta. So here it's r pi minus theta. Here if both are negative, you are in the third quadrant. To go to the third quadrant, you add pi plus theta for both. Here you are in the fourth quadrant, you put minus theta. So r minus theta, and we said here argument of z is equal minus argument of z bar. Here instead of cosine I have sine. So here you need to implement pi over 2. But cosine must be negative. Here you can see yani pi over 2 in the second quadrant is pi over 2 plus theta. Here you have it both negative and convert to pi over 2. So here we need to go to third quadrant. Third quadrant with pi over 2. So third quadrant with pi over 2, you go minus pi over 2 minus theta. I mean here, if I draw a circle, to go to third quadrant, minus pi over 2 minus theta. Okay, and here I have come in converting it. This is in the last quadrant, fourth quadrant. Because here I need to have cosine, here I need to have sine. Sine here must be negative, so I do minus pi over 2 plus theta. You can memorize these not to do a mistake. Okay, in trigonometric form, I it means 1 pi over 2 minus 3 pi. 2 minus 2i, both are the same, so always you think of pi over 4. But this is in the last quadrant, fourth quadrant, pi over 4 is minus pi over 4, and it's radical 4 plus 4 to radical 2. Here 5, it means like you have 5 0 minus 1 plus I, it's the same, so it's a multiple of pi over 4. You want it in the second quadrant, 3 pi over 4. Radically 3 plus I, this is multiple of 30 or 60. So 2, if you do tangent inverse of 1 over radical 3, it will give you pi over 6. So it will be 5 radical 2 over 2, and the angle 0 plus 3 pi over 4 minus pi over 6. 1 minus I power 42, I write it in polar form. It must be a multiple of 45, so in the last quadrant. So 1 minus I, this is here a mistake. It must be minus pi over 4 and radical 2. So it will be radical 2 power 42, it's 2 power 21, and 42 times minus pi over 4. Okay, so this is minus 21 pi over 2, which is equal to, you know, a trigonometric circle, you have 4 90s, so it's minus pi over 2. So this will be 2 power 21 minus pi over 2, so it will be minus 2 power 21 I. Find modulo and arguments. As we said, if you have here, this is in the here it must be positive. This is in the fourth quadrant, so you need to put 1 minus theta. Here you must convert it sign, you must add something with pi over 2 in the last quadrant. In the last quadrant we said minus pi over 2 plus theta. Hello, 1 plus I tangent theta. Tangent theta is sine theta over cosine theta, as you can see. So it's cosine, same denominator, and you put 1 over cosine theta. So this is r, and the angle is theta. Hello, look here. We have two choices. First of all, I'm going to look at r. R must be positive. If theta was in the first quadrant. If theta, because I'm talking about cosine, when cosine is positive, it's in between minus pi over 2 and pi over 2. If theta between minus pi over 2 and pi over 2, 1 over cosine theta positive, so this is the case. However, if theta was between pi over 2 and 3 pi over 2, I didn't continue, I don't know, I didn't by mistake. So second case, so this will be what? 1 over cosine theta will be negative. So since 1 over cosine theta is negative, so here what do you have? You have r is 1 over cosine theta, which is real, and you have with it what? Pi. And you have 1 theta. So what will be the polar form? It will be 1 over cosine theta and pi plus theta. So here by mistake I didn't continue. So this is case 1 and this is case 2 if theta between pi over 2 and 3 pi over 2. And number 4, Z4 cosine theta plus I sine theta 1 theta. Here cosine theta minus I sine theta 1 minus theta. So 1 over 1 is 1. Theta minus theta is 2 theta.